How good is my regression line? In last video we built a model and fitted a regression line. Now what if somebody comes and challenges that regression line? If that person says your regression line is wrong, how do we defend ourselves? So we need to make our regression line as good as possible. And how we do that? We can check it every time building a regression line, and what we will do is we will take one x point and corresponding y value we will predict using our line. If that predicted y value is exactly same or has very low error to the real y value, we will say yes, my regression line is better. We'll just test it over the regression line over here. So this was the model we previously built and this was the value we fitted. And let's open this data set. The data set we have worked with was with passenger and promotional budget. This was our regression model between. For value 517356 we got passenger amount 37824. We will try to fit this value into our prediction model over here. I'll just copy that and I will put it over here and try to predict with this value. So now if I run this line, it should give me a prediction value. If this prediction value is near to what was the actual y value, we would say my regression line is good enough. So we have 37231, but in our data set we had 37824. So this is not that bad, but still there is some error. So we have imagined that submitted x in the regression line, we got a prediction as y predict. So y predict should be equal to the y, or y minus y predict should be 0. So the error total would be 0. At every point of x, if we repeat the same, we get multiple error values. And those error values should be very low, and which we called SSE, which we also understood in our last video. But SSE is not a good measure. For a good model, we need SSE to be 0 or near to 0. But standalone SSE does not make any sense. Why? Because we need a scale. We need SSE to be compared with something else. For example, if we have SSE of 100 is very high, or it could be very less. When y value is varying in terms of 1000, SSE is high. If its y value is varying in terms of millions, SSE of 100 is very low. So we need the variance of y, to what extent y is varying. If we can get this comparison of SSE to the variance of y, we shall be able to get more detail on how good is our regression line. We will do this in this mathematical example. So we have error sum of square, which is SSE, can be denoted by original y value minus the predicted y value, and this error squared and sum of it. Now we have to compare it with the variance of y, which is total variance of y, which would be original value minus the mean of that particular value and the square of it, and then sum, which would be SST, sum of total square. With the sum mathematical changes, I'm subtracting it with the predicted value and I'm adding the y, which is predicted value. This is mathematically true, and I will go through this and break it down into till here. From looking at this part, y minus y cap square, we can say that this is SSE, and y predicted, which is given by the regression line point minus the mean of y, we are going to call it SSR. So with this mathematical transformation, we are going to say that the total variance SST, which can be divided into two parts, one SSE and one SSR. The part SSR is explained something called variance that can be explained by regression line, which is SSR. Variance that cannot be explained by x is called SSE, which is our total error. We will understand it on the graph. This is our regression line, and this is our original data point y. This is the predicted data point, and this is the mean of y, which is y bar, which is the total mean of y. Now from mean to the predicted value is our SST. We are going to compare the SSE to the SST. Over here SSR is the explained variance. From this point to this point we have explanation using this regression line. We know that regression line is saying that SSR till here I can predict it correctly, but this part which is SSE, which is the error. So SSR is our explained variance and SSE is our unexplained variance and SST is our total variance of our errors. So how good is my regression line? We have SST, which is total sum of square, is equal to SSE, and we have SSR. So now to my line to be good, what I need is SSE to be very low and SS to be very high. SST we cannot work on it, we cannot do anything about it because it has to stay same, but we can increase the SSR. That means that we need to decrease the value of SSE, and we will see how we can do it using R square in our next video.